Hello everyone, I'm going to explain you the procedures for radial conductor. First thing first, okay. Then we turn on the heat conduction machine. Open the valve over here, so the cold water flows through the heater, and then we should know that T1 is the nearest. See, the T1 is the nearest, and the T7 is the furthest. This experiment is conducted because we want to know the relationship between the distance and the heater, between distance and the heater, and it will affect the temperature or not. As you can see, we should turn this on, and then first thing first, we have to put the power into 30 watt. Uh, so okay, 30 watt. Then, as you can see, the T1 is higher than T7, and we shall record all the data in our table, and that's it for the experiment. Thank you.
Assalamualaikum and a very good evening to Ustazah here. My name is MADIHAH FARHANA binti FIKRI, number matric B09201195. Will present you for lab 2, which is radial heat conduction experiment. Okay, I'm going to present the result for ambient temperature 24 degree. Okay, as you can see, we already collect the data from temperature 1 until temperature 7. We already convert to Kelvin unit, and we collect all the temperature for 5 power, which is 30 watt, 40 watt, 50 watt, 70 and 90 watt. For ready from T2, already selected from value 0 until 0.06. Okay, as you can see here, the value temperature for T1 until T7 for all the power is decreasing. Example, for 30 watt, it starts from 316.5, and then it decreased to 312, and then 309, then decrease again until 307, and then 305, and then decrease again until 303, and then the last value for temperature 7, which is 302.6. As you can see, it slowly decreased from T1 until T7. But for 90 watt power, it starts from 346.4 and then continue to collect the data for T2, which is 336.4 and then 329.6. But for temperature 4 and the temperature 7, we couldn't get the exact value for the temperature because since the power is too high, then the temperature is way too hot to collect. So we don't have the exact value for T4 until T7 for 90 watt. Okay, next, this is the discussion. We have to choose one of our set of results and use the equation in the theory section to calculate the calculation which is value T2 and T3, and then continue to find the theoretical value of the other thermocouples. Okay, so I'm going to give to KHAIRIL to present the next calculation slide.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is FITRI bin Muhammad Amin. My matric number is B0920101147. Okay, Today I will explain about the calculation for this experiment. Okay, the formula that we use is K equals to W multiplied by ln R2 divided by R1 and divided by 2 pi length and multiplied by temperature 1 minus temperature 2. Okay, first we need to find the K for our experiment first, and after we get the value, which is 87.9979 watt per meter Kelvin, okay, we can find the all the temperature: temperature 1, temperature 2, temperature 3, 4, 5, 6 and 7. Okay, for the temperature 1, we use the initial temperature from the experiment, which is 316.5. So to find the temperature 2, we just rearrange the formula and insert the value from the data that we get. Okay, for example, temperature 2, 316.5 minus with 30 multiplied by ln 30 divided by 2 and divided by 2 pi 0.005 multiplied by 87.9979. Then we will get the temperature 2, which is 312 and 1 Kelvin. The unit for this temperature is Kelvin. So it's the same for other temperature. Temperature 3, 4 until 7, we use the same formula, but for the temperature we minus with the initial temperature that we get. Okay, for example, temperature 3, we use the temperature 2 that we get from earlier. So 312 and 312.1 minus 30 multiplied by ln 40 divided by 30 and divided by 2 pi 0.005 and multiplied by 87.9979. Then we get the temperature for temperature 3 is equal to 309 Kelvin. So we just use the same formula, only the initial temperature we use the previous value that we get. So all this temperature is the result that we get by using 30 watt. Okay, so we compare the experiment and theoretical data. So as we can see, the experiment for the initial distance we get the same, and next the temperature is slightly different. For example, for distance for the heat source at 30, experiment we get 309.2, but for the theoretical we get 309. And for the 40, we get 307.5 and theoretical 306.6. For the 50, 305.7 and 304.6. For the 60, the experiment we get 303.9 and the theoretical we get 302.9. For the 70, we get 302.6 and for the theoretical we get 301.5. So this is the graph. We can see at the graph the temperature for experiment and theoretical have a slightly different.
Assalamualaikum. My name is NURYN binti YATIM. Matrix number B09201007. So I will continue with discussion number 2. The question one, we discussed the cause of errors between theoretical and experimental data. As we know, there are many causes of error that we found between theoretical and experimental data. First, thermal energy may lose due to surrounding when we did the experiment. Since we did the experiment in an open area, we are not able to control the temperature. Uncontrolled situation in the experiment include the temperature variation in the room and also the further the distant water from the heater, the lower the temperature will be. So distant effect temperature of water for the experiment outcome. Next, physical contact between heating element may have not been achieved fully as the equipment malfunctions while employing the larger degree of heat. As the result, the data generated uh, as the result, the data generate will differ. Besides that, time required to record the data may vary and the power of radial heat conduction will be disturbed. Impurities in the material may cause heat to flow non-uniformly due to long time usage causing differences in data result. Lastly, color of material, type or shape of material may affect the radiation coefficient. I think that's it from me, and I will pass it next slide to the next presenter. Thank you.
Okay, so this is the conclusion for Lab 2 radial heat conduction. So based on the table and the graph, the temperature for all 5 powers are decreasing. So this proves that the larger the rings in area as their radius increases, the lower the temperature. So generally, both radial and linear conduction experiments were quite the same in terms of mechanism. As for linear conduction, the temperature will flow linearly along a solid bar of uniform circular cross-section with a gradient of temperature change per unit length. So it shows that in the picture that T1 is higher than T2. For radial conduction, the temperature would flow radially from a central heat source through a metal disc of uniform dimension. The calculation is similar to linear conduction except that the area and the thickness of the ring is shaped pieces between temperature, and also the measurement points were included. Okay, so the next one is, according to the plotted graph, increment of area in rings would yield a curved line that obeys the x power of 2 polynomial function. So when we calculated the thermal conductivity, which is K unit, all 7 temperatures from T1 until T7, this could prove that the function of insulating material, the installed insulating material that surrounded the disc, was to reduce heat loss by radiation and convection, so that the experiment result will be more accurate with the theory result. So that's all. Thank you.